just go over to it. If I can find it. Okay.
And I lost you. Oh, you went. Oh, there you are. Okay.
Okay, let's see. Okay, group meeting. All right, so I'm going to just push start.
Okay.
1 second. Okay. Oh, it keeps freezing on me.
Okay, and then 11-7 group meeting. Don't want to get it wrong again.
Yeah, yeah. Okay, so do you just want to read number 3?
Sure. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places. Okay, so go pull up the applet. Sorry, I didn't have that ready.
No, that's fine. So, okay, so they're just wanting us to find out what it is to the left and the right?
Yeah, that's what it sounds like to me. So if we fill in the shades left and right, correct?
Yeah.
Where was the applet again?
Yeah, so it's byuimath.com/apps.
Math.com/apps.
Slash.
Okay.
And
Oops.
oh, is it pulling up?
No, sorry, /NO.
RMPROB.
PROB.
.html.
HTML. Okay.
Okay.
Okay, didn't pull that up that way. Okay.
Oh, it didn't pull it that way?
No, let me try again. So BYU.
Okay, so BYUimath.
Math.com.
And then -apps.
Okay, sorry, apps. And then was it?
-NORMPROB.
.html. Okay, let's see if that worked. Yep, it did. Okay.
Perfect. Okay, so what was it? Was 0.1358?
1.358. So then we just put that in the area box 358, correct? Oh wait, that's the z-score. Whoops.
Yeah.
358.
So then the z-score would be 0.175.
Yes, that's what I got too. 0.1. Wait, yeah, 0.175.
Is it point or? Yeah, 0.175.
Yeah, yep.
Sometimes I get so confused with like the points because you're looking at so many of them. Okay,
oh, I hear you.
175.
Okay. Yeah. Okay. That one was good. Okay. And then the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in the sample. And then round your answer to 3 decimal places. Wait, did I miss a line?
I think you did. The weights of a random sample of 48 commercial boat passengers.
Yeah, I missed that. Were recorded.
I was like, wait a second, yeah.
Yeah, sorry. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed in the sample, and then round to 3 decimal places. Okay.
Okay, so pretty much.
Oh, sorry, what?
Oh, what were you going to say?
I was going to say, is that new formula?
Yeah, so it would be 177.6 minus the mean, which is 185.
Okay.
Over.
And then, let's see.
And then it would be over
26.7.
Yeah, the standard deviation divided by
is that one the 48?
Yeah, 48.
Okay.
Yeah, you totally got it.
See, I don't know why. I mean, I do this every single time, so and I'm gonna keep guessing and guessing until the end of this class, but
I know. Well, did you see that the exam, she's giving us 4 hours? And I'm like, oh my gosh. Well, that's
goodness.
either a good thing or it's a bad thing. Like, it's going to be so long. It's four
yeah, that's
hours.
true. Yeah, we're gonna have to do that much work in between. Oh, great. Okay, 7.6 minus 185. Okay, 26.7. Sorry, my friend let me borrow a calculator and I just have to remember how to use it.
Oh, that's okay.
Okay, so this is where, now let's see if I can do it. This is where I got the answer, negative 1.92.
Yeah, that's what I got too.
Oh, good. Okay.
And then we put that down into the z-score, right?
Oh, yes.
So was it asking for more or less than, above?
It was extreme or more extreme. Okay, so
Above or below the mean?
sample, sorry, I can't find it. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed in the sample. So
are they looking for like the less than and the more than, or are they looking for?
I don't know.
A random sample of passengers will have a weight that is as extreme
or more extreme, either above or below than was observed in the sample, right?
So I would think that maybe we would do the middle one.
Oh, I'm back on the applet, I mean, right?
Right.
Sorry, I was like, what are you thinking?
Yeah.
Okay.
So I was thinking maybe like we shade in the middle one and the one above it.
Okay.
Do you think so? And then do the area for that?
Yeah.
'Cause that would be as extreme and then more extreme. What do you think?
Yes, that makes sense. So the one and then above it, yes. So then did you get 0.973?
Yeah, 0.9.
Okay. Yeah, that's my thought too.
Okay. Yeah, that's what I would think because it would be as extreme. It wouldn't make sense if we did like the lower portion. So
Yeah. Yeah. Okay.
Okay. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations X, the distribution of the sample means X. This cannot be determined from the information given.
Okay. 9. Which of the following ones?
Oh, it would be.
Sorry.
No, that's okay. I think it would be the distribution of the sample means.
Okay, that was my guess too, but I was just looking through my notes just to double check on that. But that would be my guess.
Yeah, I think that's what it is. Because that one always ends up being smaller.
Yeah. Okay. So the B one then?
Yeah.
Okay, the second one, I guess. Okay, and then which of the following results implies that the spread in X, whatever, the Z, was that the Z thing?
What?
What's the little X with the line over it again?
Oh, I have no idea. Just X.
Okay. I know, because I didn't know that the U looking thing is actually an M and it's called mu.
Oh, really? I didn't know that either.
My dad, every time I've been having him help me this week, and every time I ask him, he's like, it's mu. And I'm like, okay, I thought that's a U.
Yeah.
Anyway.
No, I don't know.
Okay. So anyway, it decreases as the sample size increases. Okay, so that's a definition. And that would be, where are all my definitions? That one would be the, is that the law of large numbers, or I need to, implies that the spread decreases as the sample size increases. Yes, so it's a law of large numbers for that one, is what I got. Is that right?
I can't remember.
Okay, so well, let me read the definition and tell me if it sounds right. If the sample size is large, then the sample mean will typically be close to the population mean.
Which means it would have to decrease.
Yeah, this happens
That's
because the standard deviation will get smaller, right?
That's right.
Okay.
Yeah, you're right.
All right. Ouch. Sorry.
Okay.
I hurt my toe today and I just put weight on it and apparently it hurts really bad.
Okay, so the scores on the quantitative portion of the GRE are approximately normal distributed with mean 150.8 and a standard deviation of 8.8. Use the information to answer questions 7 through 10. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? Okay, so the Z-score we just do, isn't it 160 minus the mean, which is 150.8, and then we divide all of that by 8.8.
Yes.
Right?
Yes.
I think
yes.
So.
Okay. Yeah. Okay, so I'm sorry, I'm a step behind you. Okay, and I'm sorry, let's see. I really am a step behind you. Let's see. So you said 160 minus 150.8, is that right?
Yeah. And so
All
I think
8.8.
Yeah. Yeah, I think so. And then that's just what number we put in for the Z-score.
Okay. All right, so 160 minus 150.8. So I got 1.05, or would it be 4 or 5?
I got 4 or 5. Right?
Okay, yeah,
3 decimals.
Yep, you're exactly right. So
rounding decimals is like the death of me. I don't know why I'm so bad at it.
Me too. Me too. Okay, so 1.045.
Uh-huh.
Okay, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Okay, so then do we type in the 1.045 on the applet?
No, yeah, just because the one before was 160. Yeah, so that's right. Okay, so they were saying scoring above?
Yes.
Okay, so 1 point.
So just the right section, correct?
Yeah, 1. Okay, so I got 148.148.
0.148, yep. Okay, 0.148. Okay. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the Z-score corresponding to the sample mean of these students' scores? So I got to find the mean first. Oops. So I got 160 for the mean.
Yep.
Okay. So.
And then we plug that in. Oh.
I know.
So we plug that into the original mean, right? Which is 150.8. So why don't we minus that 150.8, and then we divide all of that 8.8?
Yes. Okay, so 160 minus 150.8.
Oh, so it would be the same as the other one. It'd be 1.045.
Awesome. I like that.
Right, because it's the same one.
Yeah.
Did you notice on the homework it kept doing that? Where it'd be like the same numbers over and over again? I'm like, man, why am I even doing all the math for it?
Yeah. I know, I hear you, but I think that's what helped me is that it was so repetitive, which originally, same thing, I was like, are you kidding me? But now I'm like, oh yeah. He did that.
Yeah. Okay, so then it says, we'll have a mean square that is greater than the mean achieved by the students.
Okay, so would that be, so are we taking the 1.045 then again and then putting it greater? Or am I, see, I always second guess myself because I get stuck.
Right. So for this one, what's the probability that 5 randomly selected students will have a mean square that is greater than the mean? Because do you remember the milk jug one where it says like 8 milk jugs out of 129?
Yeah.
Do you remember that? And how you plugged in the 8 as in you did the like long new equation that we have and you put the 8 in the one that was being squared. Do you think that's the same as this one?
Yeah. Yeah, because and this is what I forget too, is that we're answering questions 7 through 10. So yes, I get what you're saying. Yeah.
Or do you think it's just the 5 students that we did the mean for before?
What is the problem with that 5 randomly? I don't know, because would it say that those 5 randomly selected students? I don't know.
Well, maybe.
Should we just, I don't know, should we just try and get the answer and see?
Yeah, so let's do it
happens.
in the long one first and see what we get. And if we get the same as the z-score number 9, then we know for sure that we could have just plugged that in. Does that make sense?
Yes.
Okay.
So then it would still be the same 160 minus 150.8, correct?
Yeah.
Okay, 150.8. And then over.
So that's 9.2, right?
Oh, yes. Thank you.
And then.
So 9.2 over.
And then 8.8 divided by 5 squared.
Yes. Yes. Divided by 5 squared. Okay. Okay, so I got, for that answer, I got 3.935, but then we need to have 160.
Hold on 1 second.
I know, I'm sorry. And I have to talk myself through everything too.
No, you're fine. Okay, and then. What did you get overall?
So I got 2.338.
Yeah, that's what I got too.
Okay.
Oh, I don't know what to do. I don't know which one we should do.
Well, are we allowed to have my dad come look at it, do you think? Or does it just have to be us?
No, I think we're allowed to do that.
Okay, I'll have him come look at it real quick. Will you come look at this, Dad?
Tom, thank you.
Oh, I will. Your husband saved the day a couple of times. So.
Yeah.
Answered this one. And these things have helped us answer 7. It's supposed to help us answer 7 through 10. So number 10 right there. And I can show you what we did.
Where's the information up above?
Yeah.
Oh.
So that's the formula we just used.
Mm-hmm.
Okay. So he's saying that's the correct formula. So that's the answers we got.
And then we plug that into the applet?
Yes. Yep, because then it would be greater than the mean. Yep.
Okay.
Okay.
Wait a minute.
Perfect.
Oh.
Tom,
Sorry, he's
thank
just
you
double
so
checking
much.
too.
Okay.
I don't.
Okay, so once we have that answer, then we have this little applet right here. And then we enter in the z-score right there.
Right.
And then,
Yep, that's exactly right.
okay, 2.338. And then, and so it's greater than, so that would be our area.
Mm-hmm.
Does that sound right?
Mm-hmm.
Okay.
And how should we round that? Should it be 0.010 because
Go
it's
back to
10?
the question.
Sorry, just 1 second. If we're rounding that to the third decimal, would it be 0.01?
0.00.
0.01?
0.001.
Oh, he's saying 0.001.
No. Point zero. It would be 0.10. 0.010.
0.010.
Okay, 0.010.
So,
Got it. No, thank you so much.
Hey, he's a mathematician. Oh, it's to 4 places.
Oh, is that what it says?
Yeah, so 0.0097.
Okay,
On that one.
so 0.00.
Oh, good. I'm glad you caught that. Thanks, Steph.
yeah. Okay.
Okay, thank you.
Oh, thank you so much.
She says thanks.
Oh.
Man, that must be
Alright.
so nice. Well, that's good though that we did it right. I'm proud of us.
Yeah, it's. I know that's partly why I've been coming to him too, because because like I said, because I second guess myself so much, it's just nice to be reassured that you're okay.
Yeah, you're doing the right thing.
Yeah. So okay. So now suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of this sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected? So is that one approximately normal because of the law of large numbers?
Yeah, so it's actually normal because of the central limit theorem.
Yes, you're right.
But
Yes.
you're right. Yeah.
Okay. Yes. I get those two mixed up, but I do know which one is.
I know, right? Well,
normal
and it's so confusing because you're like, well, it should be that one because it's a large number and that's what makes it normal. It
Yeah,
doesn't make
exactly.
sense, but yeah.
Okay. What is the mean of the distribution of the sample means or sampling distribution for all possible samples of size 81 that could be drawn from the parent population? Okay. So this is, well, let's see. So is this that same long problem, right?
I
Or long-
assume so, but they don't have a number to plug in for the square. What is the mean of the distribution of the sample means for all possible sizes? Wait, the mean of the distribution of the sample means, isn't that always going to be, that's going to be a mean of 3.5, right? Because isn't the mean of the sample means always the same?
Yes. I
Is
get
that
tricked by
right?
that. Yes, you're right. Yep. So 3.5.
Yeah.
Okay, yes. Okay, what is the standard deviation of the sampling distribution of the random variable XE thingy, mean of the 81 students who are selected? Okay, so then now do we just use that to plug in?
Yeah, so for finding the standard deviation, then we do that 81 squared, I'm pretty sure.
Uh-huh.
And then we divide the standard deviation 0.7 by that.
Mhm.
Does that sound right?
Yes, the OE thingy over the NE thingy. Yes. Okay.
So it'd be 0.7 divided by 9. Yeah.
You
like
know what?
your
It's
little-
getting me
your
through
little
math.
phrases.
So I got, let's see, and how many to one decimal place? So 0.1?
Oh, it's 1 decimal? No, it's 3.
3. Sorry, I was looking at the wrong one.
Yeah. So 0.078, is that what you got?
Yep.
Oh, it's getting closer then. I always get so nervous.
I know. I hear
Before
you.
we submit it. Okay.
I know. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3?
Okay, so now we do the long.
The longy one. Okay.
Yeah.
All right. So that would be the 0.07. Oh, wait, 3.5. Yes.
Yeah, so 3.3 to minus 3.5.
Oh, wait, where are
And
you
then-
getting 3.3 from?
So it says less than 3.3. So we would,
Oh, yes. Okay, I'm
does that
sorry.
make sense?
Hello. Is this
Yes. So 3.3 minus
Is this
3.5.
Cheryl?
Uh-huh.
Oh,
And then we
that's
do,
right. Good. So I went and did that interview with the sister.
Sorry, I'm going to tell him to move rooms.
Down by Union Valley.
Do you see coming up?
And she said you had it.
Okay, sorry.
no, you're totally fine.
Okay, so 3.3 minus
She
3.5
said you had the-
divided by, and then, why am I missing something? What am I missing? What's the O thing?
Okay, so it would be 0.7 divided by the square root of 81.
Oh, that's what my problem. Okay, yes. So 3. Is it, wait.
I think this one is on one of the homework assignments. So what you do, it's actually the same, pretty much the same as question 13, because I mean, you do part of it. So you do 0.7 divided by the square root of 81, which we
Okay.
just got, which is 0.078.
Mm-hmm.
And then you do 3.3 minus 3.5, which is negative 0.2. And then you divide that negative 0.2 by 0.078.
Okay, okay.
And then now we put it in the applet.
Okay, I'm sorry. I don't know. I think that.
No, don't be sorry.
So 0.564, negative 2.564. Okay, so let's go put it in the applet. And then, okay, and then what is the problem that the mean will be less than? Okay.
So I think
So,
it's 0.005.
yep.
Yeah, this one was in the homework assignment, or in
Yeah,
one of
okay,
them.
Yeah, it sure was.
That makes me feel good. We know that we got that one right.
Yeah, I like that.
I know. Yeah.
Okay, so and it was round to the 3, so 0.005. Okay.
The
Then
next
what is
one's easy because then it's like what it's going to be greater than.
Greater than, yay! I love easy. Oh, wait. But wait.
Right?
Will be greater than, so
So
it's
do
the
we
same
do?
thing, right?
I think, or do we do? I think it is the same thing.
Yeah.
2.56, or do we do all of it?
Okay, let's see. Will be greater.
We do all of it, because if it ends up being negative 2.56, then we have to do the red line next to 2.56, negative 2.56.
Okay.
Right?
So yes.
Do you think so?
Yes, I
Is
know.
that right?
Yep. Okay.
Okay, so 0.995.
Yep.
Oh,
0.995.
we're all finished.
Okay. You ready? I hate this.
I hate this too. Ready? Let's do it.
Oh, we missed some, but that's okay.
We did? How many did we miss?
Well, we got a B plus, so we missed 1, 2. That's okay.
Darn it,
I'll
which
take a
ones
B
did we
plus.
miss?
So we missed number 4, which is okay. That was that long one. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185. That huge long one.
Oh, okay.
And then it's find the
And then we missed
probability.
number 9.
Yeah. So I wonder if we just selected. No, that should have been. I still feel like we knew what the answer was.
This is the area to the right of 1.045 for number. Oh no, I'm reading the wrong one. So I guess it gives you a formula. The z-square for a mean of n randomly selected values is given by. Oh, do they really want us to do all of the numbers and then add them?
That's what I'm wondering.
Oh my goodness, could you imagine?
No. Which, okay. Oh well, I mean, So that's okay. I mean, that's okay.
Yeah.
I thought we had it.
I thought we had it too, but at least we got like a lot of the other ones right.
Yeah, I agree. I know. I think we are understanding, and I think we're on the right page. I think those were just simple little.
Those ones were tricky because they weren't in like any of the homework.
Right.
And so it just was like, wait a second, how are we supposed to do it?
Yeah, exactly.
Well, that's okay.
Well, awesome. Well, cool. We'll take it though.
Yeah.
Better than an F.
Yeah. So do we know if Melissa dropped out? Do you think she did?
You know what? And since I don't know, but since her name's like not on anything anymore, I'm wondering. And she didn't reply to my email. So because Tuesday was the drop day.
Yeah.
So I wonder if she did.
Okay. Well,
but we can even email the teacher.
Yeah. Well, Allie said that she was going to do it on Tuesday. She could at 6. Are you still good with that?
Yep. I'm good at 6. And I should be good anytime on Thursday again. So I appreciate you so much. I'm sorry.
No, it's not a problem at all.
Nuisance, but I really appreciate that.
Okay. Well, I guess I will see you Tuesday.
Okay, cool. And then you're okay posting it and everything?
Yeah. Mm-hmm.
Okay. Awesome. Thank you.
You're welcome. Bye.
See you next week.